Oh, I sleep and fall. Make sure I have everything down first. Hey, yeah. All right, clock strikes 10. Let's start off first. Okay, before I actually begin, how many of you all is your first ever revision event over here? Can I just have a sensing? One, two, awesome. Amen? Okay, come. Okay, sorry for that. Yeah, slowly streaming first. Can I get your names? Come nearer, come nearer. Sorry. Not because I want to, yeah. Name, sorry. Grace Liu. Then I have, sorry, Pranata. Okay. And do you have the materials with you? Have, okay, just take a seat. Just take. Name? Wen. Wen Xuan. Okay. Do you have the material? Okay, just take one. Can I get your name? Sorry. You clean. Okay, let me try to repeat that. How do I spell? Sorry? Why? Oh, okay. I think, okay. Li Yuk Ling, is it? Awesome. All right. Do you have the material with you? Okay, just take a seat. Okay. I need you all to find some seats a little. I push my table a little bit so I can squeeze. Okay, so you can come in. Okay, maybe just push a little bit to the front. Yes, awesome. Okay, yeah. Sorry. Yeah. Can you fit? If cannot, it's okay. Push your table a bit back. My apologies. Yeah. Thank you. Can fit? Wow. I don't want my session haven't start. I already got injury already. Okay, let me settle some administrative stuff. Okay, all right. Give me a moment. Okay, settle down. Yeah, take out materials. Feel free to warm up to the atmosphere. All right, we'll start off in a while. Okay, as I was saying, okay, let me backtrack to my question. How many of you all is your first time for the revision events? Okay, one, two, three, awesome. Okay, good. So some of you have attended twice. So you may have seen this particular introduction for, I don't know, N times. Okay, but for the purpose, for those who are coming in for the first time, just bear with me. Okay, let me do my brief introduction to know that who is this teacher here that's teaching you all. Okay, so welcome to Overmark, our September holidays revision event. All right, so thank you for spending a wonderful morning with me where you can have your beauty sleep. I really appreciate that as well. So I hope you all take away some stuff, okay, regardless whether you might have learned these concepts before or whether you feel that, okay, I have mastered, I know all these questions, but what are the different ways where I can tackle those questions? Okay, this is the time for you to do so. And for me, in terms of, okay, so before I go on to how I want this class to be in the long run, it's okay. I know it's hard to adapt. Okay, let me just give a brief introduction of myself. Okay, so in summary, who is this teacher teaching you over here? All right, so I am teacher Jason. All right, there is another Jason, so that's why my surname is there. So I'm teacher Jason Yek. So in this case, what levels do I teach? Basically, secondary math, 1, 2, 3, 4, E and A. Okay, so you can be rest assured that in terms of content-wise, I'll be more than capable to help you all. Okay, so I don't want to blabber too much about my credentials over here, but basically in summary, graduated from NUS in terms of math. Okay, it's a coincidence I'm teaching math, not because I have a math degree, but rest assured with my vigorous content there, I'll be more than be able to convey what is to be taught to you all. Okay, so this one here, 70% over here, all right, it's more of a two-way communication. Okay, I don't want to be here to be like, oh, okay, I'm going to blabber throughout. Okay, here's where I'm going to emphasize on how I want to convey the class. Okay, sometimes when I throw a question, you may be like, does the teacher actually want me to answer? This is where, okay, I actually want you to actually trigger those critical thinking processes. So the topics that I'm going through today. Now, I know there are 5 topics, but I believe some of the topics that are over there, example, binomial theorem, may not be tested. So we did a little bit of Telegram poll, and we realized that there are 3 topics, then we come down to 3 topics. So 3 topics we're going to go through is discriminants, polynomials and partial fractions, and exponential and logs. Then you may wonder, sure, I come for binomial and coordinate geometry. How? Don't worry, I got you covered. At the end of the session, what happens? okay, I will screen the QR code for the answer scheme. You all can scan there. Feel free to try as and when you are free for revision. Cool? Awesome. Okay, so definitely we'll cover the main topics over here that will be for your end of years. Just that maybe the three we are not so sure. Example, one very prime example. I walked around and asked you all. Most of you are not tested for binomial theorem lah. Okay, can? All right. So in this case over here, fun fact over here also, okay, long story short, I do have a teacher's account. So if you were to follow me at the end, very simple, teacher Jason Yeh at IG. Okay, shameless advertising. Moving on. Okay, overmark here, we have 9 outlets. You guys are? Which lesson? Come in. You all stand there. The section AMF. Yeah, here. It's here. Yeah, just find a seat somewhere. You all might have to squeeze a bit, yeah? Do you all have seats? Okay, just squeeze somewhere, yes. You all might have to, one of your seat here, or you all can grab a chair and squeeze there if you all prefer. Yeah, I'm so sorry. Okay, can or you all can just take a chair and squeeze it there, it's fine, yeah. Can you all make sure you all do the own combinations, yeah? Okay, so sorry for that. Okay, later I just get your names, Hey, you all have the material by any chance? Okay, please take one first. If not, I'll be staring at the screen and trying to absorb throughout without writing. Okay, not very efficient lah. Okay, long story short, over here, all right, we have you, David. I think you can shoot there. Yeah. Thank you so much. All right, thank you for accommodating. Yeah. All right, so just very bit apologies for the very cozy setting over here, but I'm sure cozy or not, you'll get something from here. Okay, long story short, overmark. Okay, the reason why you're here is you definitely know through either Telegram, IG, or through your friends lah. Currently, 9 outlets. You are at the very cozy Bukit Timah lah. Okay, we have 9 other outlets, but thank you for coming over here. Despite maybe some of them are nearer for you. Okay, now in this case over here, long story short, we all have the credentials to teach you all lah. Okay, definitely. And again, the ballpoint mark 70% is really more of a 2-point effort, which I'll demonstrate to you all in a while as we go through questions. And also, all right, if you're an overmarked student, you get all of these except for 2 things here lah. Okay, unless you all tell me you all suddenly maybe 1 year later, oh, I want to do math practical, math very boring lah. Okay, then maybe suddenly science can change to math. Okay, touch wood lah. I know you all don't want that. Okay, I think math papers are a bit harsh for you all already. Okay, any questions? All right, if not, okay, enough blabbering. Let's get started on the content for today. Again, let me emphasize, yeah, there are 5 topics. I'm only going to go through 3. Discriminants, polynomials and partial fractions, and exponential and logs. However, the other 2, don't get scared. At the end, got QR code scan, got answer scheme, you all can practice. I hope that assures you all. Okay, or maybe along the way, maybe you all see the question during the break times, if I can squeeze in some. You all be like, how to do this question? Can give me some hints. I'll be more than happy to provide before you all. Okay, for the topics that I've not covered. Can? Awesome. Okay, let's get started. Anyway, also, along the way, if you all need to go toilet, just raise your hand, say I need to go toilet. Okay, don't shy. No need to hang in there one. Okay, now, first one, when we talk about discriminants, straight away, I know you all memorize this. Wow, discriminant. Okay, straight away we have all this content. You all should be clear. I'm just doing some refresher. Okay, straight away we know it's your b squared minus 4ac. Wow, then you all memorize over here. Okay, we have our here more than 0. This is 2 real and distinct roots. You're here for the AMF, right? Yeah, you might want to just grab a chair. Yeah, you might want to just grab a chair. Okay. Yeah. Okay, can? No worries. I will push a chair. Give me a moment. Sorry for that. Okay, so please take note of the discriminant. I get the chair one. Sorry, so sorry, Okay, there might be a little bit of discrepancy where I move a bit back and forth, so just a little bit for the 10 to 15 minutes. But I think along the way, the lessons will be quite smooth. Okay, now discriminants over here. You all naturally memorize this. More than 0 is 2 and real distinct. Equals to 0 is 2 real and equal. Now, why 2 real and equal? Because they are equal, they are real. That's why you have, okay, it's the same thing as example. Okay, you have saying, this is your root, is either x is equals to A or x is equals to A. They are real, they are equal. That is what it means. Third one over here is less than 0, no real roots. This one you all know. But I can tell you in exams, you all will panic. Why? Memorize, then somehow, wow, b squared minus 4ac is what? Oh my god, I memorized. I don't know where it came from. Okay, quick hack to get this into your memory. Now, where did my b squared minus 4ac come from? This quadratic formula, which is provided in your formula booklet. Correct? Embedded there, no need to memorize. Now, how to understand whether you have two real and distinct roots? When you solve for your quadratic equation, take note. You are solving for values here, right? Your b squared minus 4ac value is determined by the very nice and cute square root here. When you square root the value, what is the value inside? What must be the value inside here to give you a number? Positive, right? It must be a positive value so that you can get values. That's why more than 0, you can evaluate. Equals to 0, that whole thing becomes 0, you get a negative b over 2a. Less than 0, you cannot square root a negative number. Okay, over here, I'm not saying you must memorize this. It's just a hack. Let's say, watcher, I don't want to memorize. How? This is the link. Okay, understand definitely you all know the content already, but this is more of how you link the content to the formula sheet that you all have. Okay, again, I emphasize it's not about memorizing, it's about linking to the content that you all have already. Okay, some things to take note. All right, if the question actually say real roots, you need to take note. Very key thing, discriminant will combine two things: more than or equals to sign. There must be an equal sign there that you need to take consideration of. If you don't show equal sign, you're only showing this thing, that is only one possible case. Okay, second one, common mistake. Later we'll go to questions on that. If the question say, show that, okay, please don't assume your discriminant is always this case first. Is whatever to 0. Don't assume. Okay, I will demonstrate what it means later, but just take note. Third one, in this case, is you are just solving your inequality. Okay, these pointers, I know you'll be like, yeah, I understand. But what do they mean when I apply? It will all be clear later on. So not to worry. Okay, now, common cases over here when it comes to discriminant. One possible situation. You have your curve that is always positive or negative, and then you'll be like, wow, everything memorized. Okay, positive means I need to have this, and then, wow, how to get it? This one. Tell yourself, there is a reason why the concept is like this. Always positive means, again, I believe you all know this stuff, but just a hack to get you to understand why this is the case. Always positive because your quadratic curve is this way. The only way is if you have a happy face and it floats up. Make sense for a quadratic curve? Interpret from this picture. What does it mean? Floats up. Got solution? No, right? No solution. You all shake head. No solution. Less than 0. Happy face? More than 0. Don't memorize. You realize whenever you talk about math, I know most of you all, not say all, most of you all think about memorizing. No. I'm going to break that particular thinking today. Math is more about 80% understanding, 20% memorizing. Why? The 20%, some of the formulas a bit hard to get. Example, you all learn in Sec 2, why Pythagoras theorem a squared plus b squared equals c squared? I think I just tell you straight. Sometimes the proof is harder than the thing itself. An example. Okay? Following that as well, negative. B squared minus 4ac is less than 0, no solution, set face. The only scenario. Okay, common mistake over here, I think most of y'all may make. Okay, just take note. Y'all say always positive. This one and this one, somehow the mistake y'all may make is more than 0. Take note, this is wrong. Okay, I know you're always positive, everything also positive. Take note, this one, in this case, take note of the signs. Okay, just a common mistakes to take note. Can Okay, so this is really a brief understanding. I haven't gone to the questions asked yet. All good? Can just a slight note. Awesome. Now, I think y'all may wonder. Okay, when it comes to discriminants, one way to do it is to solve your inequalities. Usually the case when you solve an inequality is the thing is factorizable. What do you mean? Step 1. Quadratic inequality. One side is always more than 0. Standard when you solve your quadratic equation. Step 2, all right, you can factorize. And in this case, you just draw a rough curve. In this case over here, from this particular question, my coefficient is more than 0. Just draw the shape. And in this case over here, since it is more than 0, we shade the regions according to where it is more than 0. From the regions we identify, just like your number line, to the left is lesser, to the right is higher. That's why our solutions here. Okay, this is really a brief recap. Later on, when we go to questions, we will reinforce. Cool? Can Okay, not to worry. Okay, if you'll be wondering, watch it. You all tell me this recap, I don't understand everything. That's why I got questions, ma. Do, and then we apply. First one. Find the set of constants for which this curve lies completely above. Again, you all may think, this is one of the things that we all take note of, right? Then you all may wonder, just say this before. Let me flip the notes, let me check, okay. In exam, don't have notes to flip. So check. Lie completely above. What is the only scenario? Not sure? Blank? You got pen, right? You got pencil? You got hand, right? Draw. Rough diagram. What is the only possible scenario? Some of you may think, sure, I scared I think wrong. What if it's a set face? If you think about it, completely above. No, you still got below. This is a wrong example. Then you try to play your luck, and in this case, you realize, no, not possible to be completely above if it's this way. So the only way you have it is this possible scenario. A picture foretells 1,000 words. From here, we know this is a smiley face. So what is one particular thing we can say? Okay, just think about it in the process. Remember, I say sometimes my questions are not really meant to be answered. It's to trigger the thinking process. If you look at it, this tells me smiley face. Coefficient. This one must be more than 0. One deal done. You're done. For the first part, you haven't solved finish yet. Next one. Completely above x-axis, right? Got solutions? No. Discriminant? Less than 0. Okay? All these thinking processes must come into you, not just for this topic, but in general, whether you study not just math, science, any subject. The logic must come here. In this case, above x-axis means not sure, write out. No solutions. Breakdown. B square minus 4. I forgot my 4. For AC less than 0. Enqi, just give me a moment. Let me finish the description before I find, okay? Okay, B square minus 4AC is less than 0. You manipulate your way through. Okay, all in all, we want it to be in your quadratic equation. So just simplify and form. Okay, shift everything towards the nice part. Okay, and in this case over here, we want our coefficients to be positive. Divide everything by minus 4. Okay, over here, you may be wondering, okay, just say can factorize, but I forget how. It's okay. Immediately, you can press your calculator, find out that you have 2 roots. This is your curve, all right? You find out that it's -1 and 4. This is okay. Okay, however, if you're scared, all right, you can work backwards, and we know this is your roots. But this step, I would say, is optional. Why? Ultimately, we are just finding the parts where it's more than 0. I have my roots when you are solving, basically pressing your calculator, go to mode 522, press your coefficients, all right? And then we get this down. Yes. Minus 4. Minus 4 minus 4 plus 1. Which one? E minus, yes, correct. Okay, just a typo. Thank you. Awesome. Thank you for reminding me. Okay, so now I'm reading above the curve. Thank you so much. More than 0, again reading number line, p less than -1 or p more than 4. Really, that's it. Okay? Don't get too daunted when you see the question like this. Decipher what it means. Relate back to the concept. Can okay, so I know you all know how to do this, but over here, I want you all to streamline all the keywords fast, how you link back to the question. Okay, can get it down before I move on? Okay, good question. Over here, we no need to reject because we are finding a set of values. So as we find a set of values, this is enough. Oh, yes, correct. Thank you very much for a reminder. So in this case over here, Ray got our output point. These two must actually coincide with these two. Thank you for the reminder. So over here, we have this scenario. Take note, one mistake that I didn't notice over here myself is it must fulfill both conditions. What's the only way for it to be more than 0 in this situation? Okay, I will just number. This is A, this is B. So which one do we accept? Just small fill out slowly. B, more than 0, more than 4. That's satisfied. So P more than 4. Okay, so finalize your answers there. Okay, thank you very much. Okay, just take note of the pointers here. Can all good? Okay, questions, just ask, just shoot it out. Anything that you realize my working a bit error, it's okay, just shoot it out. Okay, can understand? Okay. All good? Okay, let me move on. Okay, now, I know when you all see this question next, you all straight away will do this. Okay? Of course, first step is to bring everything to the left. There are no issues. Then after that, I know what happens is I will foresee most of you all will do this next. Okay, now I will give you all a few seconds to think about it. Why do I say this is not correct? Okay, think about it, yeah? Okay, I'll give you a while, think about it. Why do I say for this particular question, this is not correct? Okay, give a few seconds to think about it. It makes sense from the question. Everything aligns with the info. Okay, slowly think about it. Piera, for the previous question, P must be more than 0 because it's a smiley face. Smiley face, your coefficient has to be more than 0. Okay, now back to your question. Why is this wrong? Y'all go already. Okay, good. Okay, y'all think about it already. Okay, I'm going to highlight these two keywords. And these two keywords will actually determine that once you write this, it's wrong. Why I immediately highlight this is wrong? I say that this statement is wrong. I want you all to go back to your notes right now. Scroll up. Look at pointer number B. First page of the notes. Pointer number B. Once you all read this, you all will realize that this statement is inaccurate. What did I do here? I am supposed to show that this is greater than or equals to 0. But when I write this, what am I doing? I am already very good assuming it is greater than or equals to 0, which is not correct at all. So when you have a show that question, don't straight away, wow, very happy, all view values of k, sweet, yeah, more than or equals to 0. Okay? But just check, this is a show that, so we cannot assume this is the wrong way of writing it. Okay? Online side, just check. If you all can see the screen, drop me a thumbs up. Okay? Your statement over here will be awesome. Okay. Cheryl, you might have need to actually reshare your screen because some of them can show already. All right, can see already. So just take note. Thank you. Thank you. So discriminant, what we want to do? We are working with this particular statement first. We must work throughout working our discriminant and in this case show as you expand out 12k plus 36, okay, how is this always positive? You must work your way through. And then you be like, okay, sure, I expand. Then after that, I know one thing is, you'll get stuck here. How do you then proceed from there? Ultimately, we want to show that discriminant is more than or equals to 0. Or in this case, more than 0. Sorry for that. More than or equals to 0. Now, if you think about it, you backtrack. Understand that you all may just have memorized what. That's where I want you to backtrack. When you all are solving, say when you all press your calculator, what is the best way to rewrite this expression such that it is always bigger than or equals to 0? I give you a hint. You take a negative value, you square it. What do you get? So example, -1 square. You take a calculator, you press. You get a 1, right? Positive. You take a positive value, 1 square. You get a what? Positive value, right? So it kind of satisfies this, right? More than or equals to 0. What am I trying to say is, if we can actually make this into something square, our job is done, right? Because something square is always bigger than or equals to 0. And that's where you realize how to convert. Go and dig your Sec 2 stuff lah. Basically, your A minus B bracket square. These ones. These things here. Okay, mainly these ones. As a result over here, if you were to piece all the info, you realize life is very nice. You already have this expression. This is guaranteed to be more than or equals to 0. Confirm. No need to prove. Because anything square is always more than 0. But now, don't leave it like this. It's not enough. Why? This is a show that question. When you have a show that question, all right, always ask yourself, what is a good way to substantiate further? In this case, a particular statement to actually write it out. So whenever you have a show that question, always tell yourself how to actually write it down. Straight away, use the particular proof. Since we know that this is always more than 0, write the fact. Your discriminant will always be more than or equals to 0. How to conclude? This one not GP, not English. Okay, how to conclude? This whole statement here, Control C, Control V, done. That's your conclusion. No need to paraphrase, because this one not English. They just want to show the working. The statement over here is really a formality. Okay, the statement over here, it may seem very long, very atas, but it's really from the question title over there. You take some time to absorb. Let me know if everything is okay. Okay, any questions for this? Hey, Kenna. Okay, all good so far? So realize for this type of questions, the convention really is as such. Identify more than 0, less than 0 from your discriminants. Okay, we are going to follow the flow from there. Indirectly, if you realize this, it seems like a normal quadratic inequality question. But if you take a close look, what is it actually trying to say? Range of values of k for which this function, in terms of English, this translates to more than 0, always positive. So don't go and solve as if you are solving like a quadratic inequality. Like the dongle. I think that HDMI is not working, sir. I don't have that. Okay, so it's always positive, So always positive, we call link to discriminant. Discriminant in this case. All right, b square minus 4ac. 4 square minus 4 to negative k plus 1. This is less than 0. Same stuff lah. Manipulate, solve from there. You're going to have 16 plus 8k plus 8k, not plus, sorry, minus 8 less than 0. Rest is simplification. Okay? Really linking discriminant down. Sorry for the typo. Thank you very much. 8k, therefore, yes. Okay. Sorry, morning ahead. I'm still waking up also. But yeah, the rest of it, take note, it all comes down and boiling towards my discriminant part. Okay? Got it down? The thought processes there? Can I? Okay, why is it not a quadratic inequality question again? If you were to solve for a quadratic inequality, take note, okay, you don't know how to factorize this in the first place. So what happens? We want to find out this is greater than 0. Okay, if you were to think of it like a quadratic inequality question, we know this is not factorizable. Okay, so one way to link it over here, don't trouble yourself, link to discriminants over here, as it is always positive. Okay, that's the online side. Any other questions now? No, Part B, you may wonder, okay, I want to link to discriminant, but I think one statement here will stump you all off. They may wonder, what is this sorcery? I only know more than 0. I only know less than 0. Why got this one? Relate back, lor. You only know positive, negative, right? Solving this is equals to solving or showing correct? Relate back to what you all have learned. You are always working with one side is 0. Work with this one instead. Now, what does it show? This shows that this is, okay, not always negative. Always negative is 1. It can be always negative, but in this case, and 0. If you refer to your notes that you have, okay, one situation, you can flip a little bit to page 2. It always shows always positive, always negative. Suddenly have a 0. What does it mean? Again, not sure. Don't memorize. Always negative and 0. What is the situation? Quadratic curve. Draw lah. Always negative and 0. Okay, in this case, the only situation is this way, ma. It cannot be this way because positive. So therefore, it will touch at one point. This is always negative and 0. Okay, sometimes you may wonder, oh, wow, how do I think of this? Draw it out, see what it makes sense. Once you have this, always negative part is this one. The 0 part is this one. One thing to make sure, what are we trying to solve for? Okay, first one, it's already shown. Okay, my coefficient here is going to be less than 0, which is already shown. I just need to show another fact. In this case, my discriminant is going to be, think about it. I'm going to write down all 3 choices. Equals to 0, less than 0, or more than 0, less than 0, or equals to 0. So this is 1, this is 2, this is 3. Think of it in your head. Okay, I give you 5 seconds. I know you are shy, so tell me, in this case, show me with your hands or lip syncing, depending on how strong my lip reading is. Which one will it be? 1, 2, or 3? Okay, look at it. I know some of you are shy. Okay, I'm trying to read your minds. Okay. Take a look at, only touch at 1 point, so yes, I hear a very loud 3. That's right, 3. Because touch at 1 point, ma? Alright, makes sense. Diagram drawn, everything show already. So, all we need to do, the hard work over here, find your discriminant law. Okay, in this case, before we find out discriminant, so sorry, we need to find out what is fx minus 3. So fx minus 3 is negative 2x squared minus 4x minus 2. Therefore, working with the discriminant here. Discriminant is negative 4 squared minus 4 minus 2 minus 2. 16 minus 16 is 0. Done. Touches at 1 point. And we know that based on my diagram, this and this, when we explain, based on my diagram, we can say this is fx minus 3 touches at 1 point, link back to the question. Any parts need me to clarify? Please let me know. I am working for the discriminant of this function, just to reiterate. Not this one, but this one. Yeah. Again, any parts? I've gone through quite a bit of questions already, so if there are any queries, please let me know now. Okay, I don't want to blabber, then some of you run out. Yes, let me see. Okay, why is it minus 2? All right, because I am working with fx minus 3, so it's going to be negative 2x squared minus 4x plus 1 minus 3. 1 minus 3 gives me the minus 2. Yeah, I got a lot of questions here. Okay, some of you may realize, sure, if I want to do the complete the square method, is it possible? Okay, in this way, yes, but we call complete the square. Okay, I have, let me see. Yes, you can complete the square. In this case, how you complete? Alternative way, just an add-on. More methods is better. So we call complete the square. I know when you complete the square, what you all will do? You all will factorize this part. But when I complete the square instead, I will just take note to factorize out my x squared. And for the x term, I leave the plus 1 alone. Why? Because when you complete the square, only these two things are affected. If you factor out the constant, you are causing more manipulation errors. You might forget to expand back. So just consider 2 terms instead of 3 terms. 1 less term to expand, 1 less mistake to make. Completing the square gets me x plus 1 square minus 1 whole thing square plus 1. Okay, so in this case over here, you are going to get x, okay, minus 2, okay, plus 2 plus 1, and this is the case. This is the complete the square method for those who are interested. Now, once you see this, immediately we can identify why we do complete the square. One, over here, this is the maximum point. Maximum point in this case is this. So that means my maximum value so since my maximum value is 3, can my function be greater than 3? No, right? So that's why in this case, for this particular one, This is the complete square method. Okay, over here. So Enqi, if you don't understand the discriminant method, we can go on to complete the square. Hopefully this helps. Both method works. Okay, you don't have to follow the discriminant. You realize there are both ways to do it. Whichever fits you, go ahead. Can Okay, which statement, which working, not sure, please verify. Okay, I'll be more than happy to help you all understand. Can Okay, let me move on further. Okay, any questions before I move on to this one? Can Now, third one. Yes, Rainy, you can do so. You can use the inequality way, no problem. Scroll a bit down. You mean this way? Okay. So as I'm reading this, for those who haven't complete, let's go to part C. Now, again, find the range of values. Intersect. The line intersect curve. So ask yourself, line intersect curve, what is the possible scenario? Two ways. Draw a diagram to picture if you're not sure. Somehow you lost. You decide, oh, let's do I can have this way. I can have this way. Either 2 or 1. So that means my discriminant is going to be I'm working the discriminant here. Okay, I think alternatively, I think a lot of people are confused here. Inequality way is, I have a lot of queries for the second one. So this is always, sorry guys, more than 0. This, going back to the next question, for the inequality way, flipping it, and then I add 3. Okay, I got some queries for the previous one, so sorry. Okay, therefore fx is less than 0. So over here, the inequality way is really working towards one truth. Then you work your way down. Okay, either the sentence way, or in this case, for the inequality way, I got high demands online, so sorry for that. You work your way from the fact. This is a fact. Your square is always bigger than or equals to 0. There are multiple ways, as you can tell, to solve this. So I can do the discriminant, complete the square, or in this case, you have a different method. Okay, let me know. I will check for you. Can give you all some time to absorb the different methods for part B. Okay, I'm really loving this. So in this case, any methods, let me know, yeah? Okay, can? Next one over here. If I'm working with this, take note, intersect, I am saying that it's either both cases. To play safe, I want to find the range for which my discriminant is greater than or equals to 0. Okay, but before you work the discriminant, I must do something. Because line intersects curve, you have two equations. What do you do to them? You bring them together. So one step, don't work the discriminant for this. I know this will happen. You must equate them together first. In this case, I have m plus 1 x squared plus 4 mx equals to 8x minus 2m. Inequality sign flips when you divide by a negative number. When we do this, take note, we want the right-hand side to be 0. Bring everything over. So I have Okay, you are working with this quadratic equation. I want to find my discriminant, in this case, bigger than or equals to 0. How do I work this out? Okay, same stuff. B squared minus 4AC. From there is really manipulating throughout. Make sure you understand the steps accordingly. A square minus 2ab. So I have 64m plus 64. Expanding everything out, minus 8m square minus 8m. So from here is just a mere simplification. Okay, let me just shift my steps to the left so that it's a bit clearer. Okay, after that, bring everything out. 8m squared minus 72m plus 64. This is more than or equals to 0. Don't work with too big of a numbers. If you want, in this case, simplify my numbers a little bit more. At this point, if you don't trust yourself, you can factorize, or we can actually just use your calculator. We know my function is this. Key down, you have two numbers, 1 and 8. I'm looking for this part again. M less than or equals to 1, or M more than or equals to 8. Okay, it all really boils down from intersection. So not sure, draw out, everything will flow. But the key thing is you need to know your discriminants. Okay, take some time to read through. Let me know if there are any questions. Okay, my step flow goes this way, this way. Okay, I think some of you are looking here. Let me know if you need me to go up, go down, zoom in the steps. No need to stretch your neck. Can Okay, let me move on. Can I move on? Can Next one, another scenario. You have a curve. This question, I know you all see the end statement. You all will get confused. What the heck is this? All right, write down two conditions and immediately you get stunned. Why? Firstly, you are always talking about finding the solutions. Sure. Write down conditions. Suddenly you lost. So that's where you calm yourself down. You tell yourself, go to Nirvana, breathe in, breathe out, control your heart rate. Look at the questions there. What info is given? Completely below the x-axis. What are your different conditions? This one must be less than. I think, what am I saying? What must it be? Less than 0, right? Okay, what am I saying? So this must be a set phase. One condition is down. We are done. All right? Now, lies completely below the x-axis. You are not sure what happens. Okay? You are not sure how it relates to this question. The only way we have is our discriminant. Less than 0. Apply first, see what happens. B square minus 4. Take note, this is your B. This is the A. B square minus 4AC. And then you realize, okay, what do I do from here? I know a lot of y'all will get stuck from here. Okay, y'all see the step here, y'all realize, okay, I'm stuck. What do I do next? Do I leave it like this? A and or B ma? If one of them is like this, the other one must be in terms of B somehow or other. How to show? Now, one thing over here, A square minus 4AB. Think about an expression. What's the best way we can do to this? Okay, I think I lip sync very well. Factorize. What term can we factorize out? Okay, just you all can mouth, you all shy can mouth. Okay, I factorize my A. Okay, then very nice. I have this. Then what? If you take a look at this, realize, oh, I need to solve this. How do I solve this? I don't know what's the value of A. I don't know what's the value of A minus 4B. I don't know how to put them in the inequality. I give you a hint. That is why we try to get more info. They won't leave you alone, stuck like this. One thing is, I know tendency is when you all see an alphabet, you all won't divide. But over here, A is less than 0, right? Can I actually divide A both sides? Can I? Because A is not 0. I'm not dividing by 0. That's why in this case, your teachers don't encourage you to divide, because just in case A is 0. But in this case, this is not 0. I can divide both sides. This is negative. If I divide both sides by 0, both sides by A, what happens to the inequality here? Isn't this nicer looking? So therefore, with this at the top and this at the bottom, you are done. So when you all do a question, you realize I'm not just skimming the step through. Every step has a purpose. There is a reason why you put a pen down and you write your steps. Effort put in, make sure you reciprocate. Yes. Okay, let me repeat again. Good question. No, miss, just ask. Take note. A is less than 0, right? Means A is a negative number. When we divide by a negative number, what happens to inequality? Flip lor. Because your A is a negative number. Good question. I encourage that. Thank you. Appreciate that. Negative, therefore divide by A, I flip. Why negative? Here. I don't assume, it's all from the question. Any questions? Can all good? I move on, yeah? Now, doesn't this look familiar? It's saying positive, right? So we know two key things. If it's always positive, this value must be a smiley face. So, more than 0. Actually, for this question, a little bit incorrect. Can you all help me remove this? Thank you very much. Okay, and in this case, to be always positive, next part, we know discriminant must be less than or equals to 0. Okay, just help me remove the equal sign. Sorry for that. For A, B. Same old steps at this point. Okay, discriminant B squared minus 4AC. Write it down. So I have 9 squared at 9 minus 12K. You can no need divide by 4 for the previous one. Okay, I'm answering the online one. Yeah, you can leave it like this because it's just a condition. Okay, my ID 4965543. Okay. Yep, I've answered you. Expand it out. Okay, rearrange a little. Before I divide out, I actually simplify. This is more than 0, divide by a negative number. So again, go to your calculator, press and check. You'll get 2 roots. Okay, at this point, I'll just go through same stuff. You get 2 roots minus half. We have a 2. We know it's in this case this way and this way. But take note, okay, I made that mistake once. So just take note, since this is more than or equals to 0, and this inequality, I need to have a solution set that fits this. What is that solution set? Okay, why does the inequality sign change? I'm dividing by a negative number, Vikra. Why is it less than 0? Because my discriminant is less than 0 as it's always positive, Ray. Okay, for the online, for my on-site people, any questions for my working? Any parts unclear? Can so as you all go on, you realize the steps are really the same way throughout. Always positive, always negative, intersect, tangent, floating above. We always relate to the discriminants. Because I mean this one? This one is the discriminant step. Okay, this is your first condition. This is the second condition. I'm working in different steps. These are two different steps. Okay, can All right. Let's do this one before we go for a short break. Same stuff. Yes. When you hear break, suddenly away, so hang in there with me. 5A, always positive. Draw out a diagram. Smiley face. Okay, you realize at this point, I'm just summarizing what I said. Smiley face more than 0. Always positive. Remember, don't go into the trap. Discriminant is less than. So I have my b squared minus 4ac less than 0. Okay, let me just go back a little bit. Scroll out for the rest. Okay, just focus down there. Over here, I have 36 minus 4k less than 0. So for this one, we can simplify a little bit more. This is just 9 minus k squared less than 0. So from here, you can work out your roots, but take note, in this case, when you draw your graph, it's no longer a smiley face. It's going to be a sad face. Don't need. You just have to summarize and find these answers. Just put the triple dot, Vinny. Okay, in this case, why sad face? Negative here, ma? Negative coefficient less than or equal, negative coefficient, sad face. After that, check. You are going to have two roots. I'm working for this part or this part here. Okay, therefore, let me zoom in, yeah? This is k less than minus 3 or k more than or equals to 3. Again, don't assume the solution set. Check. One is positive. These two must satisfy. The best way, positive, and this one, k is more than 3. Okay, because it has to be positive. So as I'm going through the solutions, I want to think through why am I writing these steps. Any part not sure, please ask. You realize I'm stopping every question, not to say that I'm panicking or anything, but I want you all to understand and absorb. Can Same stuff lah. Real and equal roots. Can anybody tell me for this one, what will be the discriminant? Okay, y'all can mouth it out in silent mode. Okay, I know y'all have the microphone dash silent mode. Y'all can mouth it out. Discriminant will be real and equal. Okay, y'all can think in your head. Let me try with your minds again. Y'all very shy one. Real and equal. Two roots are real equal means I only have one of them. Always relate back to the statement. But before y'all do this, take note. Your discriminant, don't work from here lah. Remember, when you are solving for the discriminant, you are working from a quadratic equation. Shift everything to the left. Make the other side 0. Then your b squared minus 4ac comes in, which is p squared minus 4 of 1 and 8 minus p. Expand everything out. P squared plus 4p minus 32 equals to 0. You're going to have two values. Just write it down. P is equals to minus 8 or P is equals to 4. Okay, so moral story for discriminants. Feels like there are a lot of different variations, but I realize it all boils down to what that means. Draw a diagram, link back towards your discriminant. Diagrams, graphs, it will help a lot. Okay, for those who wonder how I suddenly jump to this, either calculator or if you feel unsafe, this way lah. Okay, any questions? Always positive will link to your quadratic inequality rate, because always positive means your discriminant is less than 0, therefore linking to the quadratic inequality. It's not two scenarios, it's as a result. Can discriminant this one be more than or equals to 0? Trick. This one cannot. Cannot be more than or equals to 0. Why? They say they are real and they are equal. It's the same thing as saying that I have two real and equal roots. Again, recall, either x is equals to a or x is equals to a, but this is really very mouthful. Just saying in summary, I only have x is equals to a only one real root. So they like to confuse you with this, real and equal, but essentially just telling you only one root. Okay, thank you for the questions. Keep it coming. Smiley face. So in this case, Renee, your inequality over there will come because of the smiley face. Example over here. This one is going to be positive, therefore your inequality sign will come as 1 is more than 0. Or in this case, if I have to rephrase a little, I say A, since it's a smiley face view, and okay, let's say I'm saying it's always positive. Okay, because let's say this is a smiley face, I'm relating to a quadratic inequality, A more than 0. You can, okay, so any questions about discriminants, feel free to ask. Otherwise, at this point, we take a quick 5-minute break. We resume again at 11:08 over there lah. Okay, so if you feel that I need to wash your face a little, I'll proceed on to the next topic. This one, no need, Renee, all right? Because real and equal, both are okay. Okay, I'm just stating a scenario. No need to reject. Okay, come back at 11:08, yeah? No need to reject P equals to 8 because I'm just stating a scenario here. But if you have that scenario where A must be greater than 0, then yes, I need to reject. But for this question, I'm just stating an extra info. Okay, cool. Video Aiden, unfortunately, I don't have, but I think we do have prior resources. I think you can search YouTube and search from there. Alternatively, after this session, I will send the soft copy to you all. All right, cool. Of the answer scheme, so just prepare. Okay. Yeah, I'll just scoom through both lah because you all need. All right, we take 5. Okay, I have a lot of questions online. B squared, more than or equals. You combine both. Real roots can be both, can be distinct or equal. So in this case, what you say over here, my sign will be this scenario. Plus both. Yes. The one on the left. Okay, take no pointer. If it's real, roots must be the one that circle very bright. Okay. Finally, we did take 5. We resume at 11:08. Okay. Sorry, you realize sometimes I'm talking myself because of queries over here. Okay. Okay, toilet wise, there's only one. So if there's a queue, just take note lah. Okay, come back in 4 minutes time. Okay, any parts unsure, please let me know. Okay, all good, guys, girls. Any part unsure? Can able to understand? Okay, all good. Able to understand, Can all good. Able to understand? Can any sense unclear during my explanation? Please let me know. All good. Can Guys, all good. Understand? That's sweet. So that's why I felt it is like basically. Because mu and equals mu and equals the rule. Remember example when you're solving. I'm just showing an example. By right, you can write one. So example when you're solving x minus 4 bracket square, right? Essentially you got square equals square. Right? You can figure one. But the real meaning behind this one, you don't square root, example x minus 4 bracket square. If you break it up with x minus 4, then x minus 4, right? If you do it normally, by your factorization, it's despite x minus 4 equals to 0, x minus 4 equals to 0. That's the proper way. So that's why we can take from this way. But if you write it this way, it's not wrong. Okay? Yeah, that's it. Yes. Ask this. You can somehow read it, okay, I feel it in my mind, blah, blah, blah. You can feel it, right, like this. Why I draw it? Diagram for those of you. So in this case, you can straight away from here up. Okay, say no problem. Okay, but if you are not sure exactly what exam strengths we can then we watch sheet. I forget how to go. Okay. Okay, equal roots 496,543 is saying that when I solve this, I got equal roots. But when I'm doing my discriminant over here, all right, my P can be different values. P are not your roots. P are not your roots. Line and curve do not intersect each other. Prim. You ask yourself, got solutions? Don't have, right? Discriminant is? Okay, you got your answer from there. Question 2, can you solve by inequality? Question 2, cannot because you're supposed to show that you're discriminant. Remember, it's a show question, Renee? Okay, sorry, I know the toilet a bit occupying, so yeah. Okay, you are supposed to show, cannot solve. When you see a show question, you cannot solve. Okay, can all right, let's come back. Thank you for the quick break. Okay, notes very thick, but take note, we are focusing on 3 topics only. Next one is gonna be very hand lengthy. All right, so just take note over here. Be prepared to write a lot and try to know the calculator hacks lah. Okay, now polynomials and partial fractions. In summary, polynomials you will focus on 2 concepts. Why? First question, really focusing on finding the values, whacking 2 theorems over here. Remainder theorem, when you are dividing by this. Okay? After that, if you have factor theorem, I know a lot of paragraph very hard to see, so I streamline for you. Remainder theorem, you sub in and check the particular part here equals to 0. We want to find for which this is equals to 0. That's why you sub in 8. You can so long paragraph summary, focus on the orange pointer, green pointer. Remainder factor theorem. Really, polynomials, these 2. Okay. You're still highlighting, sorry. If you need me to zoom out, zoom in, just say it. No shy. Okay. Okay, next one. Factorization and solving of cubic polynomials. Now, this one, step 0, you will need to do it if the question never define your polynomials. I will actually show it later when you have questions that did not verify. Let me see. Definitely there will be one somewhere. Okay, this one don't have, but I will tell you what I mean later. Okay, step 0, if it's not defined, you must express. After that, depending on the question, you may need to do step 1. Basically, this is a way to show that you are whacking a factor. But in questions so far, they will tell you what is the factor. Then you break it down. Again, if you are confused, it's okay, not to worry. As we go along in questions, I will actually verify further. Step 3, let me check. How many of you actually are doing long division when you're factoring? Just a check. Long div? I'm assuming all long div. More of long div, okay? Or some of you actually do the second one. Okay, maybe a check. Majority of you all may do long div, but I'm gonna convince you all today that this will be preferred. It may look like you need to find 3 variables, but if you know your polynomials, I essentially can give birth straight away to 2 straight. That one straight away can think very fast. The hard part is to solve a linear equation. You all may wonder, what am I talking? Later I show you all. Okay? Otherwise, if needed, check whether we are factorizing the quadratic equation needed. Okay, then you will be able to conclude as 2 linear factors, because sometimes this one can give birth to your 2 linear factors. Okay, if you are looking to solve, if you have 2 linear factors and 3, everything equals to 0, you solve. Otherwise, if you cannot factorize this, don't shock lah. Okay, you got 2 other things. Complete the square, I don't encourage that, and your quadratic formula, I encourage that. Okay, and so a lot of steps down there, just a brief run through. All right, I will get to there in a while. Okay, I know all these steps seems like it's a recipe book, but along the way, it will all make sense as you do along from the questions. So don't memorize each step. No, math is not about memorizing. The logical thinking from the info goes down. That is where I want to emphasize. Okay, can Next one, partial fractions. Now, I know you all know the 3 different things over here. Immediately when we talk about partial fractions, these are the 3 things I need you all to take note. Okay, basically what it means over here. If you have a linear factor, you are always giving birth to a constant on top where you need to find. Any distinct linear factor will give birth to a constant at the top. These are to be found. Once you understand A, B, and C are just results of it in a way. The only difference for B is this one over here. Because it's a power 2, what do I need to do? I need to first write the first one in their lowest power. Then I give birth to 1 before I rewrite it, but in the second highest power. Third one, common mistake. I know what happens when you see square. Take note, I know when you all see squares, straight away, you all will write this. Third one, I need you all to take note. Your third factor must be irreducible. Then some of you may go,这什么是 irreducible? Very cheap. So basically, irreducible means, long story short, cannot factorize. Basically, your quadratic factor cannot factorize. Not everything quadratic means you spam this, guys. Be careful. No, must be irreducible first. Then it will be a linear factor at the top. If you note, the degree at the top is always 1 less than the bottom. Okay? Now, also take note as well, before you apply your partial fractions, this first step must check. Proper or improper. Okay? If you all forgot what is proper or improper, okay, let me just do a brief recap. Let's say I have a function fx, let's say I have a function gx. Improper basically means, okay, the degree of fx is more than or equals to, then it's improper. Degree is the highest power in the polynomial, yeah? Okay, never mind. The other one, if I say proper, it's just must be lesser than. So you must make sure it is proper first before you all do your partial fractions. As emphasized here. So moral of the story, take note when you are doing partial fractions, you're always finding your A, B's, and C's. Can just take note? All good? Okay. Alright. Let me move on. Partial fractions, now check. Please don't straight away whack my ax plus b at the top. Check whether, okay, first step, of course, check whether it's proper or improper. Okay, recall what's the degree. Highest power is 1, therefore 1. Highest power is 2, therefore 2. Degree at the top less than degree at the bottom. Therefore, proper. Okay, as emphasized here. Second one, check. Take note. Don't see squares, you see linear expression. Check whether you can factorize first or not. In this case, we can. Because this one, I can factorize as this. This is a totally different scenario. Sorry, totally different scenario as compared to this one. Be careful. These two are different from the workings we have. This is when you cannot factorize. But for my example, I have actually factorized my x squared plus 6x plus 9 into brackets. So this calls for the repeating factor, where I repeat once, followed by bringing it up again one more time. Third step, I am just making the denominator the same. If that sounds confusing, you just multiply the denominator by both sides. Okay, if that makes sense as well. Okay, so essentially, if you multiply denominator on both sides, we can actually omit this one, straight away go down there. No need to cancel, all right? If you need this step to understand how you get to the one bottom below, it is okay. But over here, I'm just saying I'm multiplying both sides by the denominator. Okay, if you are confused, take note, recall this is x plus 3 squared. I'm multiplying both sides by this. After that, step 4. Straight away substitute suitable values. In this case, what do I mean? I want to solve for a variable. The best way we want to solve is a linear equation. So in this case, I don't want my A. Okay, let's say I want to solve for my B. If I sub in -3, this is equals to 0. If you picture it, the whole thing vanishes here. Which is exactly over here as well. Your whole A vanishes. Because anything multiplied by 0, it's gone. And then take note, in this case over here, I won't say compare coefficients. This one, you just sub any nice numbers. Okay, don't need to compare. If you are scared, just sub any nice numbers. Okay, some nice numbers we can consider 0, 1, etc. to help you to solve. Okay, it doesn't have to be these two numbers. If it's used already, just sub any nice numbers if you're afraid to compare coefficients. I will demonstrate to you all in a while. Okay, I will demonstrate to you all when we talk about partial fractions if needed. Okay, any questions so far? Any steps unclear? Yeah, any questions, just ask, it's okay. No shy. You got a question? Just ask, just ask. Sure, okay. Don't scare, don't scare. I'm not gonna eat you all. Can Now, when we see all of this, first, find the remainder when P is divided by x plus 2. Recall, we are just finding the value for this becomes 0. So what value do we substitute here? Okay, 1, 2, 3 in your head, you can mouth it out. Very good. Okay, -2. In this case, it is defined, so I do P of -2. Just put in my 2. Okay, immediately sub -20. Okay, they ask you to find the remainder, so just sub in. Second statement, show that this is a factor. So when you want to show that this is a factor, take note what x value we sub and what is the n value we must get. Factor, correct. 0, what x value do we sub? Very good. Okay, I hear very nice. 4/3 and 0. So immediately sub in. Just show 4/3 cube plus 5 4/3 square. Okay, and please convince yourself this is 0 by pressing the calculator. Okay, don't confuse or try to smoke the examiner. Make sure you submit the correct values lah. If you're afraid that this one is very confusing as well, we can key in the calculator for each particular variable. Step, I mean numbers. Sorry for that. Okay, what do I mean? Okay, this will give me 64/9. Additional step to substantiate to the examiner. I actually know my stuff. Okay, plus 80/9 minus 16. Additional step if you're afraid that going from here to here doesn't make sense because you need more detail. Okay, however, for this one, you will need to write a statement because if you don't write, it's just mere substitution. The statement is this. Okay, if you don't write this, it's not mathematically vigorous enough. By factor theorem, must write down. How to write the statement? Control C, Control V. Okay, take some time to understand this before I move on, yeah? Now, any questions so far? I think quite okay, yeah? Third one, when we have this equation, when we want to show that in this case, immediately, I know you all will zoom into the last part. When we see only one real root, immediately why we try to link to? Real roots, we all touched on just now, discriminant, right? But take note, this is a cubic. You don't see 3 terms immediately, I spam my discriminant. I tell you, you spam your discriminant, wrong. Why? Discriminant only works for quadratic. So essentially, how do we link this to our quadratic? Okay, as I work down the steps, it will be clear. Okay, you will understand the rationale behind. Px equals to 0. I want to show the roots. So essentially, this goes on to finding your solutions first. Let's say if you're lost, you want to find your solutions, you break it up. And this is where I know some of you are long div, but that's where I will convince you that if I were to compare coefficients, life will be much easier. Let me try to convince you all with this 2 minutes of explanation. Now, if you actually look at the notes, what they will do? They put A, B, C, right? Then you may think, wow, I need to find A, B, C. Very chore. I don't like alphabet. Alphabet give me phobia. I don't want. What if I tell you I can reduce 3 alphabets into 1 for you to solve instead? How? Tell yourself. Sorry, suddenly fly, excited already. Tell yourself, when you divide a cubic by a linear, what is the end result you must get? Quadratic, right? Quadratic is of the form ax squared plus bx plus c. Now, how you may think? Sure, okay, you say all this, what's the heck? Here it comes. No need to focus on this whole expression here. I just need to focus on my 2 n terms. Basically, the one with the highest power and the one with the lowest power. Why? Tell yourself. The first one where you expand in, you must expand in with your x squared term to get x cubed, right? No choice, ma. It must be that case, ma. So ask yourself, 3x cubed. I have 3x. What term must be there to give me 3x cubed? Got 8 eh? No have right? Solve already ma? N term, negative 16. Negative 4. The n part, when you get, you must get a constant. I have negative 16 on the right. What must negative 4 multiply here to give me negative 16? 4. A and C is gone. Only the middle one not sure. I just need to solve for B. So the hardest part for comparing coefficients is not to solve A, B, and C. It's really only to solve for B. But how to solve for B? This one, I tell you, you got the luxury of choice. Unfortunately, this one no choice lah. You only can compare with x squared term. But what happens? You are just comparing x squared term lor. In this case, you don't even need to expand everything. Tell yourself, you have one term you have yet to use. You are comparing my x squared term. Right hand side, take note, I just need to know the numbers. The terms, I don't care. Left hand side is 5. Right hand side, you just need to find the particular ways for me to get x squared term. In this case, 3x. I must multiply by what to give me an x squared term? No choice, ma? 3x must multiply by b to give me an x squared term. That is one scenario. Identify each particular ways. The other one, what is the scenario? Only this way, ma? So, you realize when you compare like this, take note, I'm only considering the coefficients. The hardest part for comparing coefficients is to solve this. This is the hardest part when you are comparing coefficients. This is the hardest part. I am not kidding. NC, yes, if you're comfortable with long division, go ahead. But over here, I'm just encouraging you all that this method is easier. If you want to use long div, go ahead. I will not stop you. Definitely for this case, this one easy to solve, right? And we know, therefore, your px is just okay, this is the first part. That's it. So over here, I'm not saying that from this moment on, you must use this method. No. I'm just here to value add and tell you, comparing coefficients actually better for this case when you're comparing cubic. Okay, but if you want to stick to long div, go ahead. Yeah, I'm not going to stop you. I'm not going to put a knife, say, must do comparing coefficients. No. If this method works, go ahead. If long div works for you better, go ahead. Okay, now back to the question flow. Yeah, I think enough promoting this method. I want to show that this has only one real root. Take note, let's say if you're solving, okay, your cubic equals to 0. Think normally, 2 brackets equals to 0 means, okay, I will just shortcut a bit. X equals to 4 over 3. And you realize your one real root means here means for your quadratic. Because you need to show, not solve, when I'm working for the discriminant for the quadratic, it must be, okay, I only have one root. So when I'm solving for this, if I already have one root here, over here, have no roots, means when I'm solving for my discriminant, it must be, okay, this is not my discriminant. I'm just writing it out. Okay, b squared minus 4ac, so I'm working for the discriminant. You can just write my discriminant. Okay, this is -7 less than 0. Therefore, my quadratic equation has no real roots. Your real root comes from here. This is your real root. Take note. So don't get confused. You don't see roots, immediately spam discriminant. Discriminant. Okay, I'm going to repeat this like a broken recorder. Your discriminant will only work for your quadratic. Basically, ax squared plus bx plus c. You don't see anything real root, go and spam discriminant. Tolong, please. Okay? But of course, answer my question. Okay, therefore, only one real root, where my real root is this. Okay, Vikra, or actually, we keep repeating this method when we do division, so not to worry lah. Okay, can? So hopefully with this first part, even though this method is not clear, I hope I've convinced you all. But don't worry, with the questions to come, I will continue to spam this method. Okay, to tell you that regardless what happens, it will always be this case. Okay, any questions? Can I write down any notes in particular? Now, let's move on. Now, I know when you all see this, you all suddenly get stuck. Why got QX? Why suddenly got this expression? Now, if you all are wondering, this is actually more of how we express a polynomial, but doesn't matter. You all see the polynomial, I know first one you get shocked. Then after that, you tell yourself, find the values of C and D. So, if you have two things, take note, we are finding. If you have two values to find, take note, you need two equations. Okay, if you need two equations, in this case, means you need two info. Okay, in this case, your equations, you are finding C and D. Now, tell yourself, what is the one that's hindering you to find C and D? This particular long thing, right? You see, this is shocks you. Why? Because you may wonder, wow, this long thing, how do I actually make sure I just want to get an equation of C and D? How do I get rid of this? Now, if you take a long, deep look about it, this is multiplication. If you want to make an expression disappear, what number you multiply to any expression, it will sort of disappear. If I can say one of them is 0, everything is gone, right? 0 times anything, everything disappears. You only have C and D. So over here, let's say example, I focus on this. I want to make the whole expression 0 by focusing on this particular factor. What do I sub? I want to make x minus 1 0. Similar to your partial fractions, you want to make it 0. If I let this be 1. This whole thing confirm gone, ma? 1 minus 1, 0. You don't even need to care what this is. Everything is gone. You will have, okay, 2 plus 7 minus 1 minus 6, C minus D. Okay, you take your calculator, press. Okay, first part, you're going to get C minus D equals to 2. The purpose of this is the pink color part is annoying the heck out of you all. I want to make it disappear. This is multiplication. What's the best way? Okay, maybe let me not just focus the arrow here. I do it in general. If I make this 0, the whole thing is gone. Because take note, I want to find C and D. I don't care about the rest. I don't want to know what is QX. I don't want to know what is the rest. I only care about my C and D. With this analogy, can anybody just mouth it out? Let me try to lip sync again. See your lip sync. What is another value I can sub? Because I need two equations so that I can get another one of C and D. Besides 1, what is another value I can sub? I have made use of this. There's this I haven't made use of yet, right? So another value I can sub is very nice. Sub it up accordingly. I'll leave you all to do the math. Left hand side is 18, negative 4C minus D. Okay, and from there you can do your simultaneous. Okay, simultaneous, I leave it for your methods lah. Substitution, elimination, your pick. I am not going to say what you do. Okay, but for this case, I'm a bit lazy, so I do elimination. I don't want to rearrange. 1 minus 2. Okay, this is just 1 minus 2. 2 minus 18 is 20. So the reason why I do elimination, these two disappears. 5C is equals to 20. C is equals to 4. After that, you just sub in maybe to any equation lah. Sub C equals to 4 into 1. Okay, solve it accordingly. So over here is really taking note, okay, for this type, even though it's not related, try to see what is hindering you to solve. You are focusing on these two. This one is a burden. You want to get rid of it. Multiplication, how? Make it 0. Okay, any questions? Yeah. Take note as you all write down the steps. I want you all to understand, not just memorize and just write it out. Okay, understand why I write each step. Okay, now moving to B. I know, anybody still need to write? Can I? Sorry. Need to write, let me know. Okay, for those who are here, look at B, and I know when y'all see this, you start. Why? Factorize this. Then you realize, okay, where do I even start? Okay, for comparing coefficients, you cannot make use of this. Why? Because when we actually expand out, we don't know what is Qx. Qx may contain some other terms that is related here. So we cannot compare coefficients for this, Anqi. Okay? Yeah, now, for part B, I know when y'all see this, y'all get stuck. Why? Wow, suddenly factorize this. Where are my x squared terms? Where's my x term? Now this one, I know when I write down my identities, then you'll be like, some more identity. You'll be like, wow, this one I forget already. Must bring back. When you see an x cubed term, when you see a constant term, I write down first. I want to see your expressions. Do you recall what happens if I factorize this or this? If you all forget, this is where I encourage you all. There is a shortcut towards factorizing this. Anything cube minus anything cube. First two, what to take note, copy and paste, the sign stays the same. Second one, you have a square on both terms. You have a b square on both terms here. Middle term, the only difference is your sign changes. So how do you understand this? Okay, copy and paste for my variables without the cube. Your signs here stay the same, just that for this one, it alternates. Similarly, your sign here stays the same, just that for this one, it alternates. Okay, once I write this down, okay, I believe everything will come down very smooth for you. Okay, what do I mean? Firstly, of course, if you want to factorize this, make sure everything is in terms of your cube, i.e., whole thing cube minus whole thing cube. make sure your cubes are expressed this way. Then, from there, you cross-refer. What is my A? What is my B? So in this case over here, A square plus AB plus B square. Okay, once you realize, back to the question. Hence, prove that only one real solution. Doesn't this look familiar? When we look at one real solution, we are looking at the discriminant, but we need to factorize out and conjure out my quadratic. Very cute. Yeah, quadratic. I must see my quadratic. So what happens? Take note. Please don't say, you cube root, therefore one solution. Why? You do that, you don't get any mark. The burden is the word hence. That means I need to make use of, in this case, this part. Which means I must see this in your working. From here, you need to work backwards until you see this, which I think this one not much of an issue, because x cubed equals to 8 over 125. You are essentially working for multiply by 125 on both sides. Then you subtract 8. Isn't this what we did for the first part? First part, sorry. I don't want to confuse you all. From here, that is where you use the hence part. Again, it goes down to what we did for the first question. They want to show only one real solution, right? If we know from here, my one real solution is from the linear. My quadratic, again, same old stuff. Okay, in this case, not really all. B squared minus 4AC. Let me write it down. Okay, you are working from this. Okay, B squared minus 4AC, you're gonna have 10 squared minus 4 times 25. Okay, just working it out times 4. Okay, this is negative 300. We know which is less than 0. Therefore, your quadratic has no real roots. Just emphasize from what you are writing from the question here. And finalize your only one real solution. Hannah? Okay, any questions for this part? Just take a close look before I move on to the next two, which is your partial fractions. Now, next one. Once you see partial fractions, always check in this case whether improper or proper. Don't straight away do your partial fractions. In this case, if you take a close look, this one, power is 3. This one, power 1, power 2, total power 3. They are the same, henceforth improper. So before you do your partial fractions, okay, this one is a degree. So your first step to doing this is, that's where you use your long diff for this one. Okay, comparing coefficients doesn't work because you are actually breaking up what this is achieved when you're dividing this. But before you do your long diff, take note, you need to know what this expression is. So let me work at the side. Just expand this out first. X minus 3, x squared plus 2. Expand it out, you get x cubed minus 2x minus 3x squared minus 6. Plus, sorry, it's plus. After that, we arrange it to make it nicer. Okay, I am just expanding this part, yeah? From here, do your long division, and I know long division over here, most of you all know what to do. We are getting rid, in this case, focus for this coefficient here. So what happens? I'm getting rid of x cubed, 5x cubed in this case. I'm multiplying by 5. Take note when you multiply throughout, check that your multiplication here is correct. And take note, don't just work from this. When you're doing long division, we are subtracting like this. So you are subtracting when you're doing long div. This will give you 2x squared minus x plus 7. As a result, when you do long div, what are you essentially doing? From your fractions, over here, this is where I rewrite it in my brackets back, because when we talk about long division, or we talk about partial fractions, we focus on their factors. This is my quotient. My remainder is a very long quadratic, but it's fine as long as the degree above is less than the degree at the bottom. My partial fraction is for this orange color box. So then from there, when you do partial fractions, it's going to be your conventional steps from there. Okay, so just take note for this one, your partial fractions, that's your conventional steps. Yep, that is, oh, plus, thank you very much, plus 7. Thank you very much for the reminder. Sorry, yep. Now, first one. Step 1, identify the general form. Bring this up, linear factor, on top find A. The other one, because it's a quadratic, I find on top will be a linear factor. Standard already at this point. Partial fractions, that one I can say very mechanical. Step 2, multiply both sides by the denominator. Step 3, don't expand my right hand side. Find suitable numbers to sub in. Okay, so for the first one, right at the blink of the eye, we know we can sub 3. Because this whole thing disappear, I'm finding left hand side, which is you sub in, you're going to get 22 equals to 11a. Okay, this gives you a is equals to 2. Then over here, you may realize the other part a bit hard to find work. I cannot get rid of this one. This is where you just sub in nice numbers to help yourself. 0, 1. What do I mean? You let x equals to 0. The left hand side becomes 7. Okay, we know our A. A is 2. 0 plus 2 is 2. This thing is gone. I'm having C, then minus 3. This gives you 7 is equals to 4 minus 3C. All right, then you solve Negative 3c equals to c, 3c is equals to minus 1. After that, you realize, wow, I still have one more to solve. It's okay. Bring in nicer numbers for yourself. Last one, let x equals to 1. Okay, in this case over here, you are just going to have 2 minus 1 plus 7. A, 1 plus 2 is 3. Okay, we are finding B. We know C. 1 minus 3 is minus 2. All in all, we are really solving for B. In this case, is 0 lah. It is fine. Don't get shocked. It is possible. Once we have this, we are really piecing everything here. Okay, compare. A is 2. White. 2. B is 0. This is gone. C is minus 1. This is here. Okay, so take note when you piece your coefficients down, just take note, okay, take note of the workings when you have it lah. Okay, any questions? Okay, moving on to the other one, partial fractions. Yeah, sorry. You all need time, just let me know, yeah? Okay, I know it's quite long. Okay, take some time, write it down, yeah? You take some time to look through. Because over here when we solve at eight minus three, the reason why we start 3, we know summing 3 is totally solution. Now the issue is how is going to be what is the solution? Let's not any value here that is 0. Alright, so that's why I use total numbers from 0, 1. Now is 0, so that's why it's times 0. You know, very often. The other one is a random value, a very nice number. But just nice numbers. So that one you have the flexibility. This is if let's say if you have your partial fractions, you are not sure what numbers, cannot find, use less number. There is no genuine reason why you use this. Yeah. Okay, any questions before I move on to the next one? Okay, now if you all take a look at the next one, I would say it's much better. Why? Because for the next one, if you take a close look, is it improper or proper? Question 4, I'm not revealing it yet. Okay, if you look at it, let me scroll down. This is degree 2. Bottom, here is 1, here is 2, total degree 3. So therefore, already proper fraction, no need to actually do anything much for your long diff. No need to do long diff. From here, it's your special cases. First one, x is just linear a over x. Plus, second one is b. I start with 1 minus x before I raise it up to the next power. Second step, multiply the denominator to both sides. Okay, as I write down the steps, it should be familiar. After that, find your nice numbers to sub in to make sure you can solve. Okay, let's say I want to solve for A. So for A, X is 0 because here multiply by 0, B gone. Here multiply by 0, C disappear. I have A is equals to 1. ID, take note, my degree at the top is 2, bottom degree 3. It's a proper fraction, yeah? Next one, check what other numbers to sub. Okay, let X equals to 1 because I can make things disappear. If I let X equals to 1, I'm comparing for C. So if I let X equals to 1, right-hand side is just, left-hand side, sorry, is just -9, right-hand side is C. Now I may wonder, then after that, I want to find values to solve for B, but it's not possible. Then you think of nice numbers. 0 doesn't work, eh? Use already. 1 also doesn't work, eh? So in this case, don't panic. What's the next nicest number I can go to? 2 lah. Okay, use nice numbers. Think of it at the back of the head. So the nice numbers, I mean, I don't say just 0 or 1. If they are used, just pick the closest, nicest number you can get. In this case, I let X is equals to 2. Sub in, the reason why I can do this is because A is 1, I have 1 minus 2 square plus B 2, 1 minus 2 plus, take note, I know what is C, -9, 2. Looks long, but take note, all in all, I am just pressing the calculators over here to find my values. Left-hand side is -13. This is just 1. This is 2n minus 1, so minus 2b. Okay, then after that, the other side is just -18. We are merely solving for my b. The 2 here is just another nice number that I'm looking out for. Okay, it's not saying why I must choose 2. It's just a nicer number. If you want to pick -1, go ahead. Up to you. Okay, Vikram, why is it bx1 minus x? If I multiply this to here, okay, just in case for those who are confused, why is it this? From here to get, I am doing this particular scenario. Top and bottom will cancel out. That's why it's this way. Okay? Okay, I haven't answered the question yet. Final stuff, I need to break this into my partial fractions. No, my A, B's, and C's, bring it in. So my A is 1. My B is -2. My C is -9. So partial fractions, your steps are really the same, just that if one is proper, one is improper, it will be that particular manner lah. Just need to do long diff if it's improper. Okay, can Okay, now let's move on. Question 5. I know you all take a look at this and be like, okay, it's your normal conventional question. Find the value of A and B. Again, same stuff. You need two equations to solve, which means you need two info. But you realize the only info you are given is this. In this case, it looks like this question. I only have one info. How do I solve for this one where it requires two information? Now, one key thing here. This is a quadratic, right? Quadratic, check. Press your calculators. Check for yourself. Tell me, what solutions do you get? If you realize if you press, you get two values. Rewriting it for you. Now you may want to cheer. Very nice. How does this help me? Recall, when we talk about factor, this one in green is for your understanding. You don't have to write your working. If I divide out by something, I'm going to have a quotient, henceforth a remainder. Where is the two info that I'm getting? Remember the focus, the first question? We talked about what values to sub. We talked about what values to sub to actually make this 0. You can do it two ways. Why does this work? Take note, my fx is this. If I let x equals to 5, which is a factor, I will have this being 0, which is my first info, which I write it down. This is the first info. Because this is the factor I'm working with, I'm just using one of them. What value do I sub for the second one? Stated over here, it's a factor. Because it makes this whole thing 0. Take note, guys. So from here, we have minus 3 down. This gives you again, when we are solving two values, we know it's simultaneous. Okay, check 9a, 5a, that's your 14. 3b is here. I'm just bringing this over. Negative 27 times 2, negative 54. I bring over, it becomes positive. Two variables, two equations. Let me make my handwriting smaller. I'm just merely doing substitution for my simultaneous. Sub 1 into 2. Go ahead and solve. I have 14a plus 3 of 50 plus 6a. This is equals to 54. Solving and manipulating. All right, 14a plus 150 plus 18a. Okay, you get 32a equals to negative 96. A is equals to minus 3. Okay, normal steps, sub your A equals to minus 3 into... Okay, I can just write into 1. Apologies, you don't have to write this. Into 1. Okay, I have B is equals to 50 plus this. Okay, let me shift this up. Okay, so sometimes if you realize you need to conjure info, look at what you have and tell yourself, two variables, I need two information. Where can you get these two info from? You can QX is the quotient, so you get a quotient and a remainder. Okay, so in this case, it's your quotient. Now, part B over here, if you take a close look, okay, no choice. Question say must use long diff. So my method doesn't work. Therefore, you still need to know these two lah. Hang in there, yeah? So, long diff. For this one, no choice. We have to do it. My fx is this one. 2x cubed minus 3x squared minus 32x minus 15. Question say long diff. No choice lah. Let's get to it. So long diff, because it's a factor, when you long diff, just take note, you should get a remainder of 0. X squared minus, not 15, not 2, sorry, 2x minus 15. First, I need to get rid of the 2x cubed. So, 2x at the top. Remember, I am subtracting these two. Henceforth, I have x squared minus 2x minus 15. Okay, this is getting you a plus 1. Okay, all in all, when you are doing this, just take note your remainder should be 0 because it's a factor. So, your fx, I can rewrite it as 2x plus 1. Okay, take note, this one, where we work out just now, is already broken up to x minus 5, x plus 3. So, and then we are solving this. This means this is equals to 0. We have all these parts. X is equals to 5, x is equals to negative half, x is equals to 3. Okay, this one, no choice because question say long diff. Okay, but I believe this one, long diff is okay because you will also need to do it for other polynomials. Okay, can, all good. Any steps not sure, please let me know as you write down. If any steps seems unsure, please let me know. All right, all good. Okay, hang in there, yeah, almost there, almost there. Just a bit more. Okay, anybody still need? No need, Okay, now. This one, when you take a look, last one for polynomials. If you take a look at this, all right, one may say, okay, how do I even make use of the info here? Kfx has a remainder of 64 when divided by x plus 1. My term is this. Okay, doesn't matter, but I know the roots are this. Now, one thing you can ask yourself, when we have roots, where did we get them from? If you picture when we solve our roots based on the pink color part, it's either x equals to minus 2, x is equals to 1, or x is equals to k, right? If you backtrack how we get the roots, your previous step will just be doing this, right? And you got that by multiplying all of them like this, right? But take note, the keyword here is k is repeated. Repeated means, okay, I either, just now when I talk about equal roots, x equals to a or x equals to a. It is repeated in that manner. So when you see repeated, a square comes into play because when you repeat, you are making it one more time. And how I know how many times to repeat? Highest power is 4. So when you multiply out, checking the powers for each bracket, it should add up to 4. But you realize over here is negative 2. Let me backtrack. Okay, just a bit of an error. Thank you very much. This should be negative 3 for those who need to change. So sorry. Okay. Now, in this case, take note. I need to make sure the term containing the highest power is negative 2 x power 4. Over here, if you expand, do you think I'll get my negative 2 x power 4? No matter how you expand, you realize you only get x power 4. How do you conjure out the negative 2? Take note, this is just one situation. If you multiply to any variable, okay, no need to copy this down first. I can change my polynomial anytime. I want negative 2x power 4, which means when I expand out, focusing on just these terms here, I will get negative 2. That is how your polynomial is formed as such. Because highest power is 4, it's negative 2. Once you have this, you realize the key issue is I don't know fx. But now fx is in this particular manner. It goes back to square 1. Remainder of 64 when divided by x plus 1. Sub and solve. F of minus 1 is equals to negative 2, 1 plus 2, 1 minus 1, negative 1 minus k square. Take note, this number here is 64. Simplify everything, you're going to get negative 4, 1, negative 1 minus 1 equals to k square. Okay, and then you will have this. Now take note at this juncture, I really urge you all not to, let me check, negative 2, negative 4. Give me a moment. This is 1. This is minus 2. So this should be 4. Yes. Take note, when you are actually doing this and dividing by 4, you will get this. When you reach here, I urge you all, don't expand. Okay, Heidi, in this case, highest power 4, let me repeat. Highest power 4 means this is power 1, power 1. If you can repeat, I need to make sure the powers add up to 4. So that's why there's a 2 there. Okay, when you do this, back to this step. Don't expand. Why? It is of the form something square equals to a constant. If you expand, it will lead to more manipulations. I don't want. Something square equals to something. Save yourself some time. We can square root straight. No need to expand. It's something square equals to a number, ma? Can we square root the number? Yes. Break it up. This is either 4 or minus 4. K is equals to negative 5 or K is equals to 3. But take note, they want you to show K is equals to 3, so we just need to reject the other one. Because K is more than 0 as stated in the question. Okay, over here, read from the question info. Okay, now you realize you have found everything. Part 2, what is the step to do? Unfortunately for this one, it is as what you think, but it is just a little tedious here. Negative 2x plus 2, x minus 1, x minus 3 square. Because they want it in descending powers, the best way to do this, I know you all will sigh when I say this, is to expand everything. No choice. Because they want an expression, so expand from left to right to make things easier for you. So first part, I have x squared plus x minus 2. This is for this part. Right hand side, I have this scenario. Okay, to make sure that and check and know what you're expanding. After that, this is where you have the painful process. When you expand, just take note, be very careful when you expand your terms out. So I'm starting off with the x squared term, expanding to my right, brackets. So I have x power 4 plus, not plus, in this case, x power 4 minus 6x cubed plus 9x squared. Second one is my x term. I expand to the brackets. Okay, I'm just pointing to the brackets. Means I'm expanding everything. Okay, so I have plus x cubed okay, minus 6x squared plus 9x. Okay, third one, I'm doing for the green one. Over here, minus 2x squared plus 12x minus 18. From here, the painful part is simplifying. So x4, x cubed terms minus 6 plus 1, 5. Okay, so I have minus 5x cubed. 9x squared minus 6x squared, 3x squared minus, I get x squared. Okay, last one, second last one, I just have my 9x plus 12x, 21x, and then follow up by a negative 18. From there, expand everything out because descending powers. Okay, so this one painful 2 marks, but no choice. You just have to expand and make sure they say descending, so give them this manner. Okay, any questions? Okay, now you may wonder, we have 3 more topics to go through, but I repeat again, I'll only go through 3. We have went through the first 2. Last one is exponential and logs. The other 2, I will show you the QR code with the mark scheme. You all can scan, download, try. Okay, so not to worry, 1 more topic only. In case you're wondering, how come the note so thick? Okay, can Now, scroll down, let's move on to exponentials based on popular demand from the tally group that we have shown. Last one. Okay, just bear with me. This one I would say is a short one, I hope. Exponential and logs. Okay, I'm not going to elaborate every single rule here, but just an emphasis. Okay, for exponential, just take note, don't get confused between 1 and 3. These two are totally different. Okay, multiply means plus. Only when my powers are bracketed, then you multiply. Okay, also take note of some emphasis on 4 and 5 as well. Okay, same basis sometimes is neglected. Take note. Basis at the triangle there. Okay, it works like your normal numbers lah. Okay, the asterisk there is don't confuse them. Okay, just a reminder. If you feel that it's right, it can help you remember better, go ahead. Okay, logs especially, this one common mistake. Plus means multiply, minus means divide. Do not write, again, reminder, this or this respectively. Please, tolong, I give you a free reminder, take note. These two not correct. Also, take note, the other side must have the x bracketed. This is not equals to the right-hand side. So the red ones are the common mistakes I want you all to take note. Okay, and in this case, just take note, if you want to fight the war for this particular topic, okay, you just need to know specifically, especially for graphs, this one. Very important. I'll mention why later when I say specifically for graphs. Part 6 will help you a lot. Of course, you need to have your calculator with you. Okay, but this one no issues. You all confirm will bring. I hope. Please reminder, O-levels bring your calculator. Not O-level. Sorry, your end of year bring your calculator. Sorry, I fast forward. Okay. Okay, now with these rules over here, one common type of question that they will mention is something like this. Now, how do you know it's a quadratic? Okay, tell yourself, you have a power. One of them, the power is twice. Signifies like a quadratic. So that's why step 1, it looks like this. If this is unclear, please take note, write a variable to make sure you are getting all of this. After that, please be familiar with your rules. In this case, when you have E, you want to use log, as written down at the bottom part. Log when the base is a numerical value, yes. But if you are confused, actually, just use log. Okay, these two tips are things over there, but I realized, sure, my brain cannot function. Can I use log for all? Can. You can think about this as your first choice. The other one is second choice. Okay, I think this one very bright. Okay, you all need to screen your eyes. Let me use a darker color. This is your first choice. This is your second choice. Okay, and take note, log here is what? Log base 10. So take note. Okay, all these are reminders lah. Now, I know when you all have these, no issues, because equations we can manipulate. But the next one, I know you all will see it. Why? All these graphs over here. Let me guess how your teacher teach you all. See the graph, memorize the shape. If positive, go up. If negative, go down. Then you pray and memorize. Correct? But I'm going to tell you right now. All you need, exponential is okay. The heck? But all you need for logs, you want to plot log function, you just need 6. If you want to plot the graph, you just need pointer number 6. Somebody asks, why? Why change of base got to do with plotting my graph? I just want to plot my graph. Why you do this to me? Chill. Just take note, we need pointer number 6. I will show you at question 2B when we draw the graph. But tell yourself, you want sketch graph, 2B will help you. Of course, you need a calculator lah. Unless you tell me you can, okay, what is the log of, I don't know, 5? Okay lah, I give it to you. Okay? All these things, okay. But the key thing is, you need to know roughly how it looks like lah. Okay, what I mean roughly how it looks like. Logarithm, you need to make sure one doesn't touch, the other one flies up. Basically, one of them is going to stick close to the x-axis. Okay, the other one here is going to fly up to the universe or go down towards very deep down below. Okay, so basically in summary, one part is going to stick close. The other one is going to fly up or go down. Okay, you know what? Just say extend. Okay. Now I have just reduced your memory to memorizing all the shape of the curve to say in general, one part will stick to the x-axis, one part will either go up or go down. Enough. Really, you just need to know these two. Okay, keep that in mind first. When we go to 2B, I will show you the magic. If it's magic for you all. If you all know, it's reinforcement lah. Okay, just now we touched on exponential, logarithms. We touched on this as well. First thing, when you want to solve this, take note, logarithm, the bases are very important. 1 is 3, 1 is 9. Please tell yourself, when you say make all bases the same, convert to the lower base. In this case, my lower base here is 3. So log base 9, we call change of base. Remember, this one at numerator, this one at denominator, you are converting to, in this case, 3. Okay, some of it you need to be aware, like 3 is 3 square, you can bring the power down. So in this case, that's why you rewrite the equation, taking note that this part here is this part. Yes. Yeah, go ahead. Yeah. After that, you rewrite. This is this part here. Take note when you combine your logs, this part must be coefficient 1. Before we say minus is divide. After that, how you remember logs? Okay, we tell ourselves, convert logs to exponent. A weird analogy for mine. This one is the small number. It has rest at the log very long already. It wants to go out and stretch, just like someone going to the toilet now wants to go out and stretch. So what I do, it goes up a lot of energy, sees the fan here hyperactive, want to waste his energy, nothing to do, Lion King, bring the fan up. So essentially it goes out, you bring the number up. That's your exponent. In a way, it's definition. In the other way, I'm saying in just a weird manner. After that, you realize once we get this, it's really simplifying and solve. But take note, logs. Usually we check and we must reject a particular solution. Usually the negative, but check. Why? Can we log the negative value? Log 9 negative 5 over 3 doesn't make sense. Therefore, we only have one answer. Okay, as we go through certain questions like this, it will be much more clearer. I promise you. Okay, can all good? Okay, awesome. First one, immediately, let's solve log. Now, in this case, take note, don't rush towards solving. Take note, what is the base here I want to convert to? One of the bases here is a number. One of the bases here is a variable. Do we want our base to be a number or variable? In this case, numbers works better. So what happens? We focus on changing just the bottom to the base over here. Log y3. There is a shortcut for this, but I don't want to confuse you all with too many things. Change of base, I'm changing to log base 3. This 3 is at the top. This y is at the bottom. I am changing to base 3. Three, we know this is 1. Okay, therefore, in this case, we know this one. Okay, let me not use this color, too bright. This one is just this one here. So if I take the reciprocal, I will have log 3y plus 4 equals to 1 plus 2 log 3y. This is, take note, the same as this, therefore rewriting. After that, take note, the ones with the logs, I bring it to one side. The other one is minus. I do a shortcut as well. My 2 goes to the y, yeah? So I minus log base 3 y square equals to 1. After that, minus means divide. Okay, and from here is just a mere notion of bringing your logs to one side. So from here, log base. So there's no 3 here, sorry. Y squared, y squared. Sorry, y squared. Okay, this is a mere notion of bringing your 3 over 3 to the power of 1 is 3. What are we solving? Quadratic, which we can solve. Bring over 3y squared, everything over to my right, or in this case left. I'm just switching things around. Okay, solving it. Okay, just take your calculator, press y is equals to 7 over 3, or y is equals to minus 2. But we take note over here, check. There is 1 I need to reject, or maybe none need to be rejected, but check. In this case over here, you realize, if you look at the question, y cannot be negative. Okay, not negative, reject. Sorry, reject, negative. Okay, conventional stats, but over here, just reminders you need to take note. Okay, can can we log y to the numerator? The log y I didn't just move, is through building my log y3 to this, therefore like that. Okay, I'm taking the reciprocal, right, Vinny? Reject negative, usually the case, but always double check. Okay, sometimes we reject the positive if it makes the logs negative. Okay, and any questions? Okay, now you're very excited suddenly about the graph. What's the heck? Okay, let's move on. 2A. Nothing much first. Later, we take some time. Tell yourself, hence, show A is 1/3, hence B. Showing 2 values, you need 2 equations. From there, really working out what you have lah. Subbing one of the points. Use your logs. A goes over. This is 1 over A. Henceforth, A is this. Just summing and solving. Okay, I am just making use of this point for this one. The other one, hence determine the value of B. Okay, this one, we know B log 1/3 to 1. Okay, A is 1/3. Okay, anything we want to know convert to 1, we know is 0. Okay, they all may ask, how do I even get this? I will explain this in part B. First step to second step. Okay, you all take note of this first. First step to second step. Okay. Okay, let me repeat the logs again in a while. Heidi, let me just backtrack. Okay, I zoom out a little. 2 minutes. Okay, give me a moment. Now, how do I go from the first step to second step? Again, reminder. Sorry. I'm working with this. This one change of base. 3 goes to numerator. This y goes to the denominator. The base I'm looking for is this 3. This is 1. The other one stays the same. I am essentially from here to here doing 2 divide by, okay, this is my divide, 1 over log 3y, which is the same thing as 2 times log 3y, which gets your answer. I hope this is clearer. For those who are wondering how I get from here to here. Okay, I give you some time before I go on to question 2B. Okay, can okay, this is for those who are wondering. Okay, now, hack time. So, when you all see this one, part B, I know your first instinct will be, wow, siao liao lah, I forget the shape already. How do I get back the shape? Now, one thing is this. When you want to sketch the graph, usually example, if you want to sketch a linear graph, nothing given to you, what do? Just pick any random points, right? X is equals to 1, you get a y value, you plot. X is equals to 3, what is the y value? You plot. You plot points. We are going to do the same thing here. How? We cannot use the calculator for this. There is no log base. There is no log base 1/3 in your calculator. Correct? No such thing. So, here's the hack. This is the graph you need to draw. Exam, panic. You have no idea of the shape at all. It's blank. You only know roughly it shouldn't touch the x-axis, it shouldn't touch the y-axis, one flies out, one flies out, something like that. You remember something like this. Now, here's the hack. Pointer number 6, what's the rule there if you go to your logarithm function? Pointer number 6, change of base, right? Calculator got what base you can use? Ln or log, right? Isn't it the same thing if I rewrite? Can't I, from here, use my calculator to plot my points? When x is 1, when x is 2, when x is 3, when x is -1. In this case, x cannot be -1. Basically, 1, 2, 3, 5. Plot a few points. Why I use log? Log is in your calculator. Change of base, you change to ln. Immediately tell yourself from here, how useful is it? That is where? From here, you just plot a few points according to what you have. First one. Okay, plot a few points. Usually what we want to plot is usually, in this case, my x-intercepts and y-intercepts is possible. Okay? First one, you take your calculator, press. When x is 1. This is what you have lah. We know in this case, my ln will not have negative value, so this part is out for this case. After that, 1 point not enough to determine the shape. Of course, not enough. Plot 1 point, say over here lah. Okay, maybe we take reference. Give me a moment. Can always have this habit of dying along the way. Give me a moment. Give yourself a few points. When x is 2, take your calculator. Ln 2 divide by ln 1/3. What do you get? Negative value, right? So 0.630. So somewhere here, say for example. We know somewhere here. Not enough. Maybe you plot a bigger value when ln 9. Say for example. So we do again. Okay, this is -2. Somewhere here. Okay, roughly to scale lah. Roughly to scale. Okay, make sure it joins up. Okay, I purposely play cheat a bit. Okay, let's say it's here. After that, we got one trend down. Why is the other trend? Maybe plot one here, 0.5. Okay, we get somewhere here. All 4 points down is settled. Let me just extend this point a little. Sorry, I play cheat a little, but I'll get the idea. From here, the points will already determine the shape for you. All you need to do, okay, Join the points down at your side. Okay, my graph a bit bad lah. Okay, so here and here. If you realize it's not convincing enough, all these things are points that you just need to consider. Okay, maybe this one you want to extend out all the way. And take note, all these points, I did not conjure out of thin air. Okay, this one is plot your own points. So, did I memorize the curve? Did I say, this particular number, need to memorize the shape? Did I even say that? I never say anything of memorizing the curve. What did I say? Change your base. Because it's on your calculator. Plot your own points. You get the shape. That's it. Really, that's it. Okay? But of course, your criteria is you must know that this doesn't give you a straight line. That is one. Example. You must know the rough shape. Roughly how it looks like can already. Okay? You know sometimes it looks like a tail this way. Can already. Just plot your own points. Okay? And in this case, make use of a calculator. That's why they say, please bring a calculator. For your question, for your answer. Make use of it. You spend some money for the calculator, make sure you make use of it for your 4 years. Now it's 3rd year already. Make full use of it. Okay? So really nothing fanciful. If I can make sure you all do less memorizing, I will do it. This is one of them. Many more to come. Unfortunately, I cannot share much, but yes. How to know which shape to draw? ID. No need to memorize shape. Take calculator, as I mentioned, plot your own points. If 0.5 is not enough, you plot one more point for yourself. No need to memorize shape. The shape over here is just generally knowing that it should not touch here and it should extend out one point. That's it. Intercepts is basically your x-intercept, y-intercept. Asymptotes over here is basically the lines that you are not supposed to touch. So in this case, it will not touch y, x is equals to 0. Okay, basically not touch. Okay, can anybody wish me to share the heck more? I'll move on. Now, next one. This one as a result, if you all know logs, exponential, even easier. Why? When they ask you to state the number of solutions on the graph, they want you to actually force out this graph here. Because you have drawn, you need to make use of it. So how does it work? First up, we will log both sides, but in this case, with this particular base. Why? We need this log to come out. What do I mean? I need to relate to the curve, I log both sides by 1/3. This way. EX goes down. We know that's 1. So you realize by solving this equation, it's very similar to solving this one, where you're finding how many intersections there are here. All in all, you need to plot this point, this graph. Then you all say, oh, I need to memorize the graph. I forgot EX. No need. E in your calculator, right? Can plot points, right? Plot. Okay. Yeah. I zoom out. Okay, plot accordingly. Take a few points. When x is 0, we have y is 1. When x is 1, we have e, so somewhere here. When x is 2, we have e squared, somewhere here. Plot some points for yourself. E squared, okay, I cannot memorize the values. E squared is what? See, I don't memorize values one. All from calculator. 7.38, somewhere up there. After that, Not sure, at the back we came some values. When E is negative 0.5. When X is negative 0.5. Okay, it's some very small value. Okay, just nice is this one. A bit lower. Okay, but y'all get the idea, just draw a rough shape. After that, 4 points. Shape very nice already, ma. Again, these are plotting suitable points for your EX. Suitable points, you choose. This is the best thing. You can choose your points. You don't have to memorize, nothing about memorizing at all. So therefore, state number of solutions. There is one intersection here. So how many solutions? One more. One intersection, one solution. So looking at that, you just need to say one solution. Okay? So moral of the story now, when you see a sketching a log graph, I'm gonna say what your teachers will not say. Don't memorize all these shapes here. Do you want to go to the exam and wait, chill, let me memorize all these shapes. You pray, you meditate, I tell you, you confirm panic, go in blur. You just need to know, for graphs, make sure one is almost touching but not touching. The other one somehow solves up or solves down. That's it. You need to know you at least have seen this before. You don't tell me this is linear. You tell me this is linear, please revise a bit more. Okay? Just need to know one goes close, one solves up. After that, the rest, really just now, I never lie. Change of business. Change to log, change to log, press calculator, plot points, fine. Applies to both exponential, applies to both logs. There is really nothing much of memorizing. I don't believe in memorizing a lot when it comes to math. Okay, as I was saying on my teaching style just now. Okay, certain formulas, if I don't want you to memorize, I will not ask you to memorize. Example, except for maybe, as I mentioned, a squared plus b squared equals to c squared, back to sec 2. That one, the proof harder than the formula. So I will just let you all say, just get it. Okay, now, 2 more questions to go before we are done. Find the value of 10x. 10 power x. Now, over here, you check what is the equation we have. Okay, go back to the graph. Okay, sorry. Let me zoom out for the rest. Okay, give you a moment. From the equation, check. How do we get 10 power x? Okay, can you realize, okay, I'm going to zoom in later. First, copy and paste the equation. Okay, I'm going to zoom in later. Don't worry. You are not going to screen there. Okay, then afterwards, ask yourself. I want to get 10 power x. Okay, very ugly. Okay, no need to cancel your writing. I just find my handwriting a bit ugly. I'm just going to rewrite. Don't worry, it's the same thing, just that I'm going to rewrite it nicer. Now, when we have this, take note, you want 10 power x. That means I want all my variables one side. First step, plus means multiply. I'm separating in terms of my indices and powers. Second one, minus means divide. I'm separating it this way. Remember what's my goal? Find the value of 10 power x. Variables all one side. Looks like you are stuck here, but take note, your powers are the same. Only the bases are different. What happens? 2 times 5, 10. Okay? So we want to find a value, you want to find a variable left-hand side, constant right-hand side. Because this has a variable involved. So always remember when you're solving your equation, learning from Sec 1 where you introduce algebra. Yes? Huh? No need. Because you want to find 10 power x, there's no need to find the actual value of x itself. You want to take log can, but it's a bit long. You can take log to find the exact value of x, then you work throughout, but no need lah. Okay, answer is this, so we make use of that. So back to my thing, you want to find variable equals to a number when we are solving an equation, where you start to learn in Sec 1. So that's where we backtrack. Variable equals to subject. In this case, this has a variable involved. Learned in Sec 1. Okay, can all good? So why I say this, and in this case, we try not to be too... Okay, let me share my thinking thought process after I go through everything lah. Part B, solve. Okay, typical question already lah. But take note, look at this. What's the base I want to take to? I have 9, I have 3 lah. Okay, smaller base. So before you convert to the smaller base and be very happy, take note, don't torture yourself. 2 is there, bring it up first. Step by step. After that, this one is the bugger where you need to change the base. Change to log base 3. This one can stay the same. Okay, this one, you need to know is 2. Cannot memorize how? Pointer number 6. Go one side. Okay, I forgot what is this. I got my calculator. So how? Work at the back. Okay, I convert to a base in the calculator. Let's do ln 9 over ln 3. Key calculator, what you get? 2. If you forget that it's 2. If you forget that it's 2. This one is if you forget, let's say exam pending, there's a reason why you bring calculator. That's why I say rule number 6, if you master it, very powerful. And so even just now, let's say, what if I do not know that? Okay, this one since I'm sharing lah. What if you do not know that this is 0? Let's say you forget. Or calculator lah. That's why all you need to do, if you are stuck, rule 6. Remember, change your base. That's it. This is only a last resort if, let's say, your brain really blank out lah. Really blank out. Okay, now back to context here. We know this is half. Okay, I'm going to bring here 2 plus log 3x. Okay, I know this is the power rule, so I bring over 2.5. This gives you this way. I shortcut a bit. I bring this over. Okay, this gives me minus means divide. After that, your logs, take note, the log comes out. Carry the 2, 3 power 2 is 9. So all in all, wait sorry, this is negative 3. I bring it over to both sides lah. But if you get 7x equals to 3, also can. Okay, again, sometimes I keep saying, well, log base 3, you all must memorize is 2, cannot how? Change your base law. You got 2 bases you can use in your calculator. Ln, log, please make use of them. Please make sure you make use of your calculators until you cannot, don't say cannot see the thing lah, but just make sure you really make use of them. He can you take some time, understand, and you realize over here, I am not going through stuff that I'm not reteaching you stuff. I'm going through some certain hacks that you can go to, especially when you have your trusty aid. Right, all good, Okay, one last one, then we are done. Okay? Again, if you look at this looks confusing, minus sign, but if I rewrite it like this, Okay, just bear with me. This is 8 at the top. In this case, divide means 2 power 3. If you write it like this, it's a bit unclear. But once you take a look at this, 1 is power x. 1 is twice the power. So when you see this picture, quadratic equations is coming. How to make it clearer? 33, 2x, 8 at the top. I rewrite this as 2x whole thing square plus 4. This one still cannot read. I'm just rewriting such that you have a nicer looking quadratic equation that you can solve. Okay, in case you need colors to see, 2x becomes y, y, y. After that, this is where the realm of math is still not too bad. You are just multiplying your y squares throughout, bringing over everything to one side. And from there, you can choose to factorize or simplify a little. Y is equals to 8 or y is equals to 1/4. From there, we know y is 2x. Okay, and then you may wonder, sure, I know x is 3, x is -2. But I forget how. Ln 8 over ln 2, wet calculator 3. This is if you exam panic, you forget that it's 3. I'm just saying if you exam panic, relax. If you know it's 3, just write 3. If you don't know, write log. Don't get scared. No need to do log. I know some of you, why need to do log? This is if you panic during exam. Yeah, I will give you alternatives to go to. Don't worry. The other one, okay lah, I no need to log lah. Okay? X is just -2 lah. But I can apply the same way. You log both sides, you bring the x over, divide, done. Okay? Can Again, don't get shocked by this. This is just a escape route if you really brainstorm. But if you just want to write x equals to 3, go ahead. I'm not going to stop you. And wait. All good? Can Okay, I think you're left with this. Last part, viewer context style. Nothing too fanciful. You just need to know, in this case, for this question, and in this case is this, T is this. So in this case over here, you need to find what is K. You need to find out what is the number. You need to know where is the information. After 10 years means what? T is 10, N is 1200. Sub in and solve. Take note, they want the exact values of K. So just take note from there. E is equals to 10K. Once you realize you just only have one variable, and just give me a moment, let me finish up this. Okay, I have 2, 3 minus 2, E 10K. Okay, I bring over, so I have -2, E 10K equals to -1. This then gives me E of 10K equals to 2. They want exact form, so if you see E, ln both sides. If you see K, this is your exact lah. They want exact value, so that's why I leave it like this. Okay, but let's say if you're lazy to key this in your calculator for your working, right one side, what is the 5 significant figure. The orange one is for you to take note when you write your working lah. Because I know this particular value is hard to key in. Okay, so just write one side. Okay, I want to write this instead. Okay, you can key this in. You don't have to write the fraction because I know it's very annoying. Okay, part 2. Find the exact number of years. Okay, this one they want exact, so sorry. So I need to use this. My apologies. I didn't read the question carefully. But it's okay. A bit troublesome. In this case, they say when n is 15,000. I am working out for, because they want exact form. No choice, we cannot escape. 2e, this whole thing multiplied by t. Okay, sorry for exceeding. I'm almost done. After that, divide my 600 throughout. Okay, rest of it, manipulation. In this case, bringing my 3 over and taking note of the negatives. So I have 6 minus 5, 1 over 2. After that, you cross multiply. Okay, this is for question 1 exact form lah, so no choice. Ln both sides. Okay, and then you simplify from the side. Okay, maybe some of your test calculator, you realize, it gives me an exact value, 20. So you just divide over first and check lah. Okay, so part 2 is not the manipulation I'm looking for, but really noting what info you need to use when you are finding your particular values lah. Ln 2 over 20, ln 2 over 10, really? Can. Can Any questions for this one? All good? Can Okay, just take note what you need. Okay, don't worry, I will flash the answer schemes for you all later on for the parts we didn't finish. Okay, benefit of doubt, question. Okay, all done with this? Can Okay, slowly. If you haven't done, just shake your head. I will display one, don't worry. This one not speed writing. This one is for you all to understand. You can okay, slowly. Okay, for those who are done, you all can breathe a bit lah. Okay, let me just do a little bit of formalities. Okay, can okay, NC, I'll just scroll to number 3 for I think this one. Okay, I give you a while before I do my formalities, yeah? I know you're looking out for the answer scheme, so just bear with me. I know. Okay, all good, Okay, awesome. Now, again, just a few things to take note, okay? 3 hours, I know very long. A2, sorry, you're in the toilet. Okay, give me a while, later I show you. Okay, 3 hours, I know it's very long, but I hope you take away something from here. Again, the purpose is not to make you all relearn stuff, but to make sure you all get some shortcuts and understanding behind the concepts to answer the question. That is my main goal. Okay, if I have to reteach you all can do it in YouTube, you all can do it in or ChatGPT ask you all to teach, right? No need to come here. So, again, this is a little bit on the side. If you want a free full scare pad, okay, if you find this is good, scan the QR code. I'll wait for you all to actually do it. If you find it is useful lah. If you all need a free full scare pad. Okay, but the thing is I need to see the Google review first. So if you all want, I give you all some time to scan and then show me lah. Okay, please over here, this is Bukit Timah. Don't do the review and suddenly say at Tampines. Here and Tampines a bit far. Okay, you all scan already. Just take note for those who need. Okay, can Okay, all good. Okay, can I give you all some time for those who wants to scan. Okay, now, also another thing, this is nothing I say first, you don't need to pay for anything. Okay, it's just for you to log in. If you scan and register, you are entitled to these things when you actually register. You do not need to pay for anything. It's really to lock in your position here. No need to pay. There is no downside for you. So if you are interested to sign up for the classes, if you find this useful, okay, you just need to fill in the form. They will reserve a slot. There is no payment needed to be done. Okay, again, I don't want to say anything. It's just something that I want to share if you find this useful. As a result, also, if you want to look out for my classes at my site, over here, I got EMAth, AMAth. Today, AMAth, so it's Tuesdays 5 to 7. Okay, so if you're interested, maybe this slot is not for you, but if other slots are better, you can scan the QR code over there. Okay, so that's it for today. Thank you, everyone. Let me just stop the recording first.